Hi, I'm John Paul Raj, and in this video, we'll solve question number 2 from paper 3, May 2025, time zone 2 for IB Mathematics Applications and Interpretations. Let's go. The following question compares the distance and direction between cities on a flat surface to the distance and direction between cities on a sphere. Interesting. Consider a model where the cities of Bogotá, Moscow, and Nairobi lie on a flat surface. Flat surface is something like a map. So, a two-dimensional map, as opposed to be, what do you call that? Globe, So this is the model on a map on a flat surface. In this model, Nairobi is 6,000 kilometers due south. Now this word due, whenever you read the word due south or something like due west, okay, let me read the sentence in completion. Give me a second. In this model, Nairobi is 6,000 kilometers due south. Okay, Nairobi is due south of Moscow, and Bogotá is 12,500 kilometers due west of Nairobi. Okay, let me just explain what this due means. Okay, in the not just in the IB, I think in mathematics, definitely, due south. Whenever we read the word due with any of the directions, south, due north, due east, it means exactly 90 degrees. So when you see due south, that means Moscow and Nairobi exactly, they lie on that perpendicular, right? And in the same way, when it says Bogotá is 12,500 kilometers due west of Nairobi, that means this line joining Nairobi and Bogotá in that direction, because when it says west, you're talking about something in the left, right, but along a perpendicular. Okay, so that's 90 degrees. Okay, so that's how you have to interpret the word due. Okay, so due east, due west, due south. Keep that in mind. All right, let me just erase these parts. And then find the distance from Bogotá to Moscow. Now clearly this is a right angle triangle, so the distance from Bogotá to Moscow, this is just the Pythagoras hypotenuse. Okay, the formula for the hypotenuse. Find the bearing of Moscow from Bogotá. From Bogotá, off Moscow, right? Off Moscow from Bogotá. So you have to draw it from the north, okay? From the north to the line joining Bogotá and Moscow. And clearly we can see that angle should just be that 90 degrees, because as we said already, that's that 90, right? If you subtract the angle inside the triangle, again, clearly we can find that using tan inverse, arctan of these two values given here. You can find that, and once you find the angle inside, then 90 minus should give you. That's all. So actually question 1 is done. I've already explained. I think you should be able to solve it, right? Let's just solve it. Come on, let's just do it together. So first one is A with the hypotenuse. Let me just see if I can just go down and solve it right here. Okay, so 1A, it says Bogotá distance from Bogotá to Moscow. Actually, inadvertently, yeah, what I was trying to do is that when you discuss a solution, it goes so fast, right? When you write, it takes time. That is the point, okay? That is the point. Writing, practice writing, and through this video, if anything that I've taught is that, through all the playlists, just write, practice writing, One is discussing, but you get graded for what you've written, and you get docked for what you've not written, right? So practice writing, okay? Distance from Bogotá to Moscow is just the hypotenuse, formula for the hypotenuse using Pythagoras theorem. So it's just under root of 6,000 square plus 12,500 square. I just want to make sure that I've got the numbers right. And is it kilometers? Yeah, it is kilometers. So just punch this into the calculator. Let's just jump over to the calculator quickly. And this is question number 2. So let me just quickly make sure that I've inserted a new problem. Calculator page 2.1. Okay, and just jump over square root, and this is a 6,000 and square plus 12,500 square, and hit Control Enter. And for some reason it's giving in that form. So let me just go in. These are the things that we should tackle, okay? See, I've used this calculator now. Maybe I've changed the settings, and you should know, okay? Sometimes kids freeze when they see this, all right? So let's just go and change the settings. It's approximate, and that's where that needs to be changed. So when you go to exact, sometimes, yeah, If you can read it off E4, what that E4 means, that's fine, okay? But that's not the point of the video. But I've seen kids freeze, okay, the moment they say E4, okay? So, oh my God, that's also a lot. That's the exact form. So why did it give that? So let me just explain that E4, what it means. Well, when you pull the digit down, you could see that, right? 13865.42, rounded off, of course, to 3SF as it gives there. And what do they say in the question? Do they say anything? They just said find the distance, right? They've not said anything of rounding off. Okay. They've not just said anything of rounding off, okay? Because the others are like 0, 0. So I don't know whether it's just 3SF. They're not said, but you have to give your answer in 3SF because that's what the IB prefers, okay, to 3SF. So let me just explain what that E4 means when you're just reading E4 from a calculator first, okay? So in this particular question, they've not said anything, but the IB prefers 3SF. Let's just keep that in mind. Let me just explain first the E4. So when you see on your calculator 1.39 E4, it literally should be translated like 1.39. E is basically times 10 to the power of, and that 4 comes there as it is, okay? So had it been an E minus 4, it means times 10 to the power of a negative 4, okay? Now how do you translate this? Is basically 1.39 times 10 to the power of 4 is basically 139, 1, 2, 3, 4, and you put the 2 zeros there, so it's basically 13900 kilometers, okay? So just to help you see that, 139 and then 4 zeros, and obviously because of the 2 decimal places, you can round it off to 13,900 kilometers. Okay, so that is basically what we're going to write down here, 13,900 kilometers. Hope that made sense. Okay, part B, find the bearing of Moscow from Bogotá. So this time, as I said, let's just use the tan inverse. Oh, there's some questions here. I always get into a trap here, right? So B part, question 1. Sorry, this is 2, B. Did I write 1 there? I think I wrote 1 there. My God, this is 2. Okay. That's the way to check, going back and forth. You can see while writing, I'm making mistakes. I think that's the basic idea, right? While writing, anyone can make mistakes. While talking, of course, we think that we've got everything. Yeah, demonstration. Find the bearing of Moscow from Bogotá. All right, we'll find the tan. So we could say that the tan of the angle MBN, all right? So maybe what we can do is that in order to show working, how many points is it out of? It's 3 points. So yeah, maybe it's a good idea just to show that. Here, do we have to write using GDC? I think we need to. Yeah, it's basically just say, you can say using GDC. Because, paper 3 is all about writing and how you write, because this part need not be written, okay? This part was just to explain to you what that 1.39 E4 is, but this is all that you would have written, and maybe just even mentioning using GDC would help, okay? And then maybe you can also write down 3SF just to be on the safe side, okay? So let's come to 2B now, and here what I wanted to say was just draw that, okay? And just say that this is 90 degrees, this is 6,000, and this is what, 12,500, I believe, and this is your, what was that? M, N, and B, M, N, and B for each of them, and you can then write down, once you've labeled it, then you've clearly said, what it is all about, then you can say the tan of the angle MBN should just be that 6,000 divided by 12,500. Can you guys see this color? Yeah, that's okay, that's visible. So that means the angle MBN must be the tan inverse of 6,000 over 12,500. And once you've written that, you can then just say using GDC. So you've actually labeled everything, written down everything, and then you said that, I'm going to use my GDC. So tan inverse, and then you can quickly jump to the calculator and say, all right, I want the tan inverse, go here, tan inverse, and quickly you can see that it's in radians. So we need to change that, okay? Tap that to radians, to degrees now, okay? And then let's just bring this thing, 6,000. And you have 12,500 here. Okay, and let's see what we're getting. We will get 25.6. 25.6. So let me just come back and say this is 25.6. Now remember, this is degrees, but it's the angle inside the triangle. This is 25.6. That angle inside the triangle, all right, needs to be subtracted from 90, as I explained, because looking for the bearing. They asked, the question is, find the bearing of Moscow from Bogotá. So if you reviewed your theory, you know that the bearing is the angle measured in the clockwise direction from the north to the line joining Bogotá and Moscow, and that's why we said 90 minus the angle inside, which is the first part we've done is finding the angle inside. Let me just continue this side, and then you can say therefore bearing of Moscow from Bogotá. This is where we write down the words. Should be 90 minus, what is that? 25.6. And then we can go back to the calculator again, and we can say, okay, 90 minus, I will bring back all the digits as I always do. Okay, can you see that? So it's rounded off, so it preserves the accuracy. And then when I go and hit Control Enter, I'll get 64.4. Okay, so this is 64.4. Coming back here, 64.4. This is again mentioned using GDC. Always a good habit to practice that, okay, using GDC. Now, whenever you write bearing, you have to report it as 064. You could have left it there, okay, and if you want, you can put the 0.4. So you can left it, because it's 3SF, I think it'll be a good idea to do 064.4. Bearing always in the first digit, it should be in 3 digits, okay, before the decimal. That's the nomenclature of bearing, is such that you write it in 3 digits before the decimal, and if there isn't a hundredths place, you leave it as a 0. So, and even if it's like, you know, like 1 degree bearing, you have to write it as 001. So write in the comments what would be a 70 degree bearing. Bearing of 7 degrees, how would you write it? Mention that in the comments. Okay, that is just a joke, if you can understand the hidden joke. Okay, I just want to keep an eye on the timing also, because I talk too much. Oh my God. All right, let's just do at least one more part. In reality, okay, so this is for the flat surface. In reality, these 3 cities lie on a curved surface, on the curved surface of the Earth, which will change the distances and directions found in part A. Cool. Now consider a curved model using coordinate system XYZ with its origin O at the center of the Earth. Okay, that's the origin O. The units of the system are thousands of kilometers. So this is okay. This was kilometers, right? This is okay. This is okay. All right, fine. What is it? Thousands of kilometers. Okay, so if it says 1, it means 1,000 kilometers. And the Earth is modeled as a sphere with radius 6,000 kilometers. So that means they must have marked it as 6. The North Pole P lies on the z-axis or z-axis, and Nairobi N is modeled as being on the equator and lying on the y-axis. So that's Nairobi along the y-axis. North Pole P, z-axis or z-axis, however you call that, and there's the x-axis. Okay, P has a position vector of 006, obviously, z-axis, and that's P bar. N has the position vector ON bar is N bar 060. Okay. B says use the scalar product to find the angle between P and N. Well, you know that the geometry says that it must be 90 degrees. Okay, but they say use the scalar product. That means you have to use the scalar product. Okay, but you can use the calculator, and I'll show you quickly how we are going to use the calculator, right? So again, for part B, to B or not to B, we say using GDC. Quickly say that using GDC, and then I'll quickly show you what that using GDC is. We want to find the angle between P and N, right? So we'll just first define that. Let me show you. So we go to the calculator, and let's just define these 2 vectors first. Okay, so it's P and N, right? So what I mean by define is P and the symbol to the right of 9. Okay, colon and equal to define anything, and we just go here on menu and vector and create a vector, and we want what is it? It's a 3 by 1. Okay, so I'll just go matrix, and number of rows is 3 and number of columns is 1. Okay, so hit enter. There you go, 3 by 1. That's a vector, right? And now we go 006, 0, 0, and I say 6, and therefore P is defined. In the same way, we're going to define N. Okay, so N is defined as, go back again. Well, you know, shortcut, just go and bring that thing down. Now you just change that, okay? I just change that to n, and then you can just edit that to 6. I believe that was 6, right? Yeah, and then make the 0. Don't forget to make that 0. Hit enter. So you got the vectors p and n. All right. Remember, whatever you do on the calculator, just show it. So that was critical. Okay. So using GDC, you have to show that you've defined. We'll copy that in a bit. Okay. Then you can come to menu and you can go to vector and you can just look for cross product. Okay. So I can just go here. Vector. Can you see that? Vector cross product. Do you see that? There you go. So I just say cross product. We're looking for cross product. No, we're looking for dot product. To show that the dot product is 0. When the dot product is 0, then the angle between them is 90, right? Use a scalar product to find the angle between, yeah, just show that the dot product is 0, okay? And then I come here and vector and dot product. I say dot product and it is just p, comma, n, all right? And once you say that, it'll say 0, and then you can just use the theory. Did you see what I just did? All right? And if you didn't see it clearly, pause, go back and see how I got the dot product, okay? But how are we going to write the answer, okay? Using GDC, you can just put it there, right? So you can say using GDC, you defined p as a vector 0, 0, 6, and the vector n as, because we are writing on paper, make sure that you use that bar. It's a vector. Otherwise, it shows as, on the print, it will show as, bold, right? So these are small things. Please pay attention to that. Okay, when it's printed, it'll show as bold. But when you're writing, make sure that you're writing the bar because that's a vector. Okay, and similarly, this vector is 0, 6, 0, and then you can say that. I'll just put a line here. I'll just say that p bar dot n bar equals 0. Using GDC, this is what you found out. Okay, therefore the angle between p bar and n bar must be 90 degrees. Okay, that is good. That is good. Okay. Show that the distance, next part is show that the distance between p and n along the arc from p to n is 3000 pi kilometers. Show that the distance is basically the arc length, I believe. So I'm just going to do that thing here. So this is B2, right? Yeah, 2B, the second part. And the angle between them is 90. We've just shown that, okay? I'm just wondering whether they would expect you to do the entire working of the dot product. Not really, because you're using the calculator. The calculator is allowed. I suppose this should be fine, okay? As long as you said that the dot product is 0, and you can say since dot product. If you want to say that since the dot product is 0, the angle must be 90 degrees. That should be good because it's just a 2-pointer. Show that the distance between p and n. Okay, we have come to that part. So you can say arc length is theta. So you can use the word distance between p and n along the arc from p to n. Okay, distance, instead of using the word arc length, the distance between p and n along the arc from p to n. And if it takes too much time, as it is taking too much time, you know what? The best or the smartest thing to do, just write down required distance. Required distance. That's short, cute, and it still preserves the idea what we're trying to do, right? Required distance is equal to theta, which is 90 over 360 times 2 pi r, 2 pi, and the radius, we're going to use 6, but you remember it's going to be translated as 6,000, okay? 6, all right? So this then can be, we can say using GDC, all right? And they want in terms of pi, remember? They want in terms of pi, so we'll leave the pi as it is and jump to the calculator again, and we can say we need theta. That's actually 1/4, but even then we'll just write it down, okay? 90 over 360 should be 1/4, right? So 90 over 360 times 2 times pi. Use this letter pi, and the r is 6, or you can even enter. Did you say 6? Yeah, it is 6, right? And then if I just hit enter, what do I get? 3 pi. 3 pi is basically 3000. Remember that it's basically per thousand. So we can say 3 pi. Okay, And then we can write down, which is the same as the 4 required distance is 3000 pi kilometers, because every unit is one, where do they say that? Yeah, the units in the system, thousands of kilometers, right? So every, if it's at 6 here, that means it's 6,000. And if it's 3 here, it says 3,000 kilometers. All right, that's all the time that we have for this particular video. We will continue solving this question in the next video. If you found this video useful, do make sure that you like, share this video and subscribe to my channel. All right, if you visit my channel, you'll find several other videos there. Do check them out. And if you have any question, any topic, any concept that you'd like explained, do mention that in the comments and I'll make a video for you.